All right. Thank you all for coming so early. Today we will talk with you about our presentation, Transforming Credit Analytics with a Compliant Lakehouse at Rabobank. My name is Floris Hendricks. I'm a product manager at Rabobank, and I've been working now approximately 5 years in the data and AI space. And recently we collaborated a lot with Taras to bring our Lakehouse to the next level. Taras is a senior resident solution architect at Databricks, and has been working there also more than 5 years. So before we start, we have a little bit of disclaimers. Everything what we show you today are our own views and do not represent the views of Rabobank or its employees. So now we have done that, let's go to the agenda of today. We will start with our business context, so how do we use and make models of credit analytics? Then how can Unity Catalog help with that? Taras will walk you through the steps, how we went from a Hive metastore to a Unity Catalog. Also the upgrade framework that was necessary and that we made to do this at scale at an organization like Rabobank. And finally, we have some results and some Q&A at the end. So let's start with Rabobank. Rabobank is the second largest bank in the Netherlands. And our mission is to growing a better world together. It's not only that this is our mission statement, this is also how we structured the company. We don't have shareholders, but we are a cooperative bank with members. And together with the members and the organization, we decide where we invest the profits in the communities. We have a lot of retail products and wholesale products in the Netherlands, but internationally we also have a large wholesale banking operation. And we do this with more than 49,000 colleagues. And the bank is relatively old. It's more than 125 years old. So yeah, just to put it a bit in perspective. Then here on this image, you can see where we are active in the world. So the blue countries are countries where we are operating. This follows from our ambition. So we want to, improve our home base, strengthen our home base in the Netherlands, but also become the food and agri bank of choice globally, and also be the market leader in vendor finance. So I added this slide not only to show you where we're active, but also to visualize a little bit the data problem that we have. So we make models at group level. So we use the data from all over the world, and all the operations are nice, but it also means that a lot of data is being created all over the world that we need to aggregate and combine. And we don't do that with one organization, we do that with some subsidiaries as well. So that gives you a little bit of the flavor where the data comes from and where we're talking about. Now let's zoom in at credit analytics. So credit analytics is the department I work for, and we make credit models, mainly regulatory credit models. So in credit modeling, you try to predict the probability of default of your counterparty, and when the default occurs, also the relevant losses. This is, of course, for a bank really important to do. And we do that in multiple type of models. We do this, for example, for IRB models. IRB stands for internal rating-based models. And normally, a bank should follow the standardized approach by a regulator, but if your operations and data is good enough, you can apply for an IRB license and can use these kind of models to calculate your regulatory capital. So how much capital a bank should hold. You can use these kind of IRB models for that. And if you make your own models, you can tailor it a bit more to your own kind of operations. And we also have different kind of models like provisioning models, which follow from the IFRS9 framework. We make these models from scratch. So we do the data collection, we make the models, we do the implementation, and also keep on the monitoring to make sure that the models are performing on par. And it helps us a lot by making better credit decisions and risk management, and also make sure that we're in line with regulatory compliancy. These models, and especially the outcomes, are really used at scale in the organization. So we use them in all kind of normal business processes in the bank. So it's just acceptance. So we accept a client, we run them through the model in the backend and see if this client fits in our risk appetite. We also use them to price the products, for monitoring the clients and try to prevent defaults. And finally, also for regulatory reporting, so the reports that we put in our financial statements and to regulator. So just, now that you know how these models work and how we use them, and I can keep on going on here about these models, but let's focus a little bit on the data that we need to make these models. As you can imagine that these are used a lot in many processes. That also means that they're strongly regulated as a bank has a certain role in the economy. So when we go live with these models, we need to go for external approval. That's something that is characteristic in our model lifecycle, which may be not always the case with other companies. Moreover, the data that we need to train the models is often quite a long horizon. So we're talking about 10, 15, sometimes even 20 years of horizon of historical data. And that also means that, we need to integrate a lot of systems from, the data doesn't always sit in one system. So we need to take the data from that system, and bridge this all together to get one nice consistent data set. And that is quite a challenge. As you have seen in the previous map, that the data come from all over the world, and there's quite a fragmented data landscape. And we do that at scale, so we don't do that for small niche portfolios, we do it for the major portfolios of Rabobank in that sense. Okay, this is going to be a complex graph, but let me do my best to explain this to you, what we mean by this. So, as I said before, is that we have a complexity that we need to have data systems where we get the data from, and also, we have different regimes in regulation. For example, if a client is in default or not, true or false, how hard can it be, right? But sometimes the rules of a default is changing. So I give you a fake example saying that first it was 120 days, and at some point the regulation become more strict, and then it becomes 90 days. So if you don't pay back 90 days on your loan, you are in default or not. And if historically the historical definition was 120, we cannot use this true-false Boolean anymore. We need to take the lower granular data and project that new regulation on top of that. So as you can imagine, that's quite a lot of business ruling that we need to do for this. So yeah. So in this graph, you can see a little bit the journey that we make. So we get data from different systems, we get regulations. So we need to make sure that at the end of the day, we tailor and adjust this data such that it's consistent through time, but also up to par to the latest definitions. And as we do not own the data, so we have a lot of data owners across the world, we need also a lot of alignment with them. So it's not that we can take the data and do whatever we want. We need to get alignment with them. So there's a lot of business ruling to get everything nice, but also there's a lot of complexity because of the collaboration that we need to have with all the stakeholders in the bank. So it is complexity in, by the work, but also a lot of stakeholder alignment. That makes it quite a difficult, but also interesting problem to work on. So on high level, we see that it looks like this. So we have data, financial statement data, all this kind of data that we get into. We get it in different formats, different level of data management has to be applied to it. Some come more in modern file formats, sometimes a little bit older file formats. We take it all, we convert it. In our medallion architecture, we do bronze, silver, gold, and then we get delivered the data products to our customers, which are also working on Databricks and can make the models from there. We noticed that in this setup, we get quite some challenges, which were mainly coming from the Hive metastore. So we had fragmented governance. We didn't have out-of-the-box data lineage, which is also a regulatory request. So we needed something to bring our Lakehouse to the next level. And with Unity, we will see later that this was a good opportunity. So to summarize, right? So if you look at Databricks, it brought us a lot. We could break our silos, unify the data. Our runtime increased a lot. So we go from weeks to sometimes hours now. And we can also combine the popular language like Python and SQL. But we are ambitious, we want more. We need to bring our data lakehouse to the next level. And with Unity Catalog, it's the tool that does that for us. So we can get now table and column level lineage at runtime, so not anymore afterwards. So when you run your code, afterwards you get your table and column level lineage. Also, we can now manage our data and give the right people access to it. And finally, something my favorite thing is actually also the system tables that gives a lot of detailed operations insight in how your operation works, so you can get much more detailed and optimize your workflow. So now you can see that the Unity Catalog was an interesting proposition for us, and Taras will show you how we went from Hive to Unity.
Floris, now that we know why credit analytics needs Unity Catalog, before discussing how do we deploy it at scale, let us take a step back and understand what does it actually mean technically to move from the existing security models to Unity Catalog. So you can see on the left, we have thousands of workspaces running for years within a bank. So each of these workspaces have a Databricks managed Hive metastore with databases containing tables and views, so does not provide support for unstructured data, so ML model, no support for ML models, AI and BI assets, so volumes, matrices, and so on. Identities and access controls are managed separately at each workspace using different security models. So service principal, cluster service principal, workspace-based service principals, credential pass-through. So a bunch of different security models, so fragmented governance as pointed out by Floris. So it does not, those security models do not provide column and row level security. So Unity Catalog on the right provides one regional metastore for all your data and AI assets, so not just structured data. It provides one unified security model across all these different AI and BI assets across different business units. So then you can attach Unity Catalog metastore to your workspace, and that will activate UC on the workspaces. So once UC is activated on the workspace, the existing use cases running on the non-Unity Catalog compute, you can see it at the bottom, continue running as is, so nothing breaks there. Then you can start onboarding your new use cases to the Unity Catalog compute at the top, and then you can plan your migration of the existing non-Unity Catalog workloads to the Unity Catalog, and we'll cover that later. So what are the key differences between those two security models? So non-Unity Catalog compute authenticates to the storage using service principal. So cluster scope service principal or workspace scope service principal if you mount data on the workspace using DBFS mounts, or even using credential pass-through, so using user credentials to access the data. There's a lot of ACLs to manage, right, on the storage. There's, on the cloud storage. It does not provide, the security model does not provide table and column level lineage, so you cannot see your upstream and downstream dependencies for your tables. And data access log is also a challenge, so it's hard to see who accesses what, especially with service principal-based access model. So Unity Catalog at the top uses Databricks managed identities to access the storage. It provides one security model on top, so using role-based access control down to the column and row level, and also attribute-based access control, which is currently in beta. So it's very easy for their even non-technical users to manage the access. So using policies, using UI or APIs and tooling on top of it. So all the read and write attempts are automatically captured in the Databricks managed system tables. And data lineage is also captured in the system tables. So the end goal, once all the existing use cases have been upgraded to Unity Catalog, is to decommission the Hive metastore infrastructure on the existing workspaces. And that feature is currently in the public preview. So from the end user perspective, just wanted to call out that Unity Catalog, Hive uses a two-level namespace to reference tables and views. So database.table. Unity Catalog uses a three-level namespace. So it has a catalog, which is a container for the databases. So catalogs provide data isolation boundaries for different business units and different software development lifecycle environments, so your dev, test, production environments. So Hive metastore becomes just another catalog. So now, how do we deploy Unity Catalog at scale? So when we say at scale, in Rabobank, we have hundreds of different teams, multiple different platforms, so it's very decentralized. So we don't want these different teams to keep reinventing the wheel all the time. So what we need to provide a framework that would encapsulate the best practices, that would provide a blueprint for Unity Catalog rollouts. That framework needs to use automation and tooling so that different teams can reuse it at scale. So we built this framework with Credit Analytics team. So we hope that this framework will be reused across the entire bank. So I'm going to give a quick overview of the framework, the 3 phases, and then we'll zoom in into each of the phases. So the phase 1 is the one-time setup of the one-time setup of the Databricks account and the regional metastores is the responsibility of the central Unity Catalog team and function. This central team also needs to provide self-service capabilities to the business units so that they can provision their business unit level infrastructure, such as catalogs, external locations, and so on. So phases 1 and 2, Unity Catalog setup phase and Unity Catalog migration, is executed by the business units themselves. So Unity Catalog setup phase has 3 steps. So first step is design and planning step, executed by business unit architects and platform admins. Step 2 is identity setup. And step 3 is the Unity Catalog infrastructure for business units, so catalogs, external locations, credentials. So once Unity Catalog BU level infrastructure is set up, then data teams can go and migrate their use cases in 2 steps. Step 1 is the table migration, and step 2 is the workload migration. So now let's deep dive on these 3 phases, starting from the UC foundation phase, and the first step is the account setup. So one Databricks account on the left maps to one Entra ID tenant on the right. And there are multiple different subscriptions owned by different business units under the Entra ID tenant. So that means that the Databricks account and the regional metastores are shared between those different business units. So we need a central team or function to manage it. So that central team and function has 3 main responsibilities. Number 1 is to configure Databricks account. So there's things like feature enablement at the account level, configuring Databricks scheme connector to synchronize users and groups at the account level, and managing high privilege roles, which is account and metastore admin roles, including user access to those roles using privilege identity management from Entra ID, as well as creating service principals with delegated metastore level privileges, such to create business unit level infrastructure. So those service principles would then be used in the infrastructure as code pipelines and NPIs provided by the central team, the foundation team, to the business units. So those infrastructure as code blueprints would provision the following infrastructure: catalogs, external locations, activating Unity Catalog on the workspaces, delegating privileges to the data teams. So essentially, central team enables business unit platform admins to manage their Unity Catalog infrastructure at scale and under control. And when we say under control, we want to make sure that certain organizational standards, security standards, are encapsulated in those infrastructure as code blueprints. So things like Unity Catalog quotas, how many catalogs do we want to allow for the business units, how many storage credentials, naming conventions for the catalogs, and so on. So this infrastructure is usually managed on a dedicated workspace, usually provisioned on a dedicated admin workspace owned by the central team. So now once this shared infrastructure, Databricks account, regional metastores is set up, now it's time for our business units to roll out Unity Catalog. And the phase 1 is the Unity Catalog setup phase. And the step 1 is design and planning step, which is executed by the business unit architect. So design and planning step starts from the workspace assessment. So we use UCX tooling provided by the Databricks lab to help us to do the UC migration at scale. So it needs to be installed on each workspace using as workspace admin needs to install it. And once it is installed, you will see a bunch of workflows. It provides also a CLI. So one of the workflows, so Databricks workflows like is an assessment workflow. When it is executed, it gives you a report. So that report gives you a visibility into the technical complexity of your Unity Catalog upgrade. So it gives you how many tables, what are those tables, external, managed, delta, non-delta, how many groups, user, ACLs, service principals, and so on. So that output from the assessment provides an input to the design and planning step. There are a couple of other important design decisions you need to take as part of the design and planning step. So number one is identity design and role-based access control. So are you going to lift and shift the existing groups and access controls from the old security models, or do you want to leverage the new capabilities, like maybe the new groups and the granular access control capabilities of the Unity catalog? Number two is catalog designs and external allocations. How many catalogs do you need for a business unit? How many external allocations do you need? And number three is upgrade planning. So you want to make sure that your upgrade phases are clearly defined, taking into account your upstream and downstream dependencies. So let us deep dive on this, on the design and planning step. Let's imagine we have a collateral data product in credit analytics. So collateral is a valuable asset that acts as a security for a bank loan. It combines data from multiple different data sources. Two of them are customer and loan data data products, and produces a data model, which is then queried by BI dashboards. So how do we upgrade it to Unity Catalog? Step one, we need to first upgrade the upstream data products, so our customer and loan data products. So customer data product can be upgraded to Unity Catalog first, which is good. Loan data product is owned by a different team with different priorities, so it cannot yet be upgraded to Unity Catalog. And we'll deal with some of the complexities later. Then, before actually upgrading our workloads, we need to upgrade our tables from Hive to Unity Catalog. And here we use UCX tooling to do this migration. So once all the tables have been upgraded from Hive to Unity Catalog, then we switch our consumers, our BI queries, to the Unity Catalog to make use of the three-level namespace, right? Catalog schema.table. So once all the consumers have been switched to the Unity Catalog, now it's time to move the jobs. And once the jobs are moved, so actually we cannot yet decommission the Hive metastore, since, as we said, the loan data product cannot be upgraded yet. So what it means that we still, in this collateral data product, we still use Hive tables, combine Hive tables with Unity Catalog tables. Means that we combine two security models. We still need to keep the service principals and the access from the old security models, and UC, right? Another issue that we don't get the lineage, the upstream lineage from the loan data product. We don't get it from Hive. So what we recommend is to use high metastore federation. So high metastore federation can be enabled on the loan data product, on the upstream data product that cannot be upgraded to Unity Catalog immediately. Then the Hive tables would be federated to Unity Catalog. So that the consumer, right, our collateral data product, would be able to use one security model, and you would also get the upstream lineage from those tables. So we are planning to make use of it, and we are waiting for some important features to land this quarter, which is support for the UC native tables in the federated catalog. So if you don't know what it is, I highly recommend checking it out, the high metastore federation. All right, so now once the design for our business unit, Unity Catalog design is ready, migration phases are clearly defined. Now it's time for our business unit platform admin to provision identities, groups, and users, and to provision catalogs. There are three steps in the identity management. First, you need to make sure that your groups and users are defined in your identity provider, so Enter-ID in our case. So identity provider is a single source of truth for our users and groups and service principals. And number two, you want to make sure that those users and groups are continuously synchronized between your identity provider and Databricks account. And here we use Databricks account level scheme connector to do that. It has a few limitations. One is it does not support synchronizing nested groups, which we did not need in credit analytics, but we know that we're going to need it for other BUs. And it does not support synchronizing service principals. So we are planning to make use of automatic identity management. It's a new feature. It's currently in the public preview. To automatically, so that workspace admins can simply pull the Enter-ID groups, and they will get automatically synchronized to our account level, to our account. So it supports syncing nested groups and service principals as well. So number 3 is the enabling identity federation. So once identity federation is enabled, you can assign your account level groups to the workspaces. So notice that the existing workspace local groups are not automatically upgraded to Unity Catalog, to the account level. So here we use UCX tooling to do this, to upgrade our workspace local groups to the account level. So it also migrates workspace permissions for these groups. So the second part of the Unity Catalog infrastructure setup for our business unit is catalogs and external locations. So number 1 is actually the platform admin needs to create a Databricks managed identity and grant it access to our data. And number 2, 3, and 4 is actually using the infrastructure as code capabilities provided by the foundation team to create the catalogs, external locations, and to grant certain privileges to our data teams. And finally, number 5 is we want to grant permissions to use Unity Catalog Compute to our data teams. So now, since our Unity Catalog infrastructure for our business unit is set up, so now it's time for our data teams to upgrade their data products, so their data engineering, BI, and machine learning, data science workloads to the Unity Catalog. So we're going to focus on the BI and data engineering workloads. So there are 2 steps. First is table migrations, and second step is the workload migration. I'll keep it short. So the table migration, on the left, you can see your Hive tables, our collateral tables. On the right, you can see the Unity Catalog infrastructure that has been provisioned by our platform admin, so the catalogs, external locations. So we use UCX tooling to upgrade the Hive tables to Unity Catalog. So UCX table migration supports different types of tables, so external, managed tables, delta, non-delta, and it uses different strategies with or without data copies to upgrade those tables to Unity Catalog. So it also supports you have an option to upgrade the existing ACLs from the service principal-based access model to the Unity Catalog as part of the table migration. And finally, the workload migration. So first, we upgrade the consumers, as we said before, followed by the jobs. So one common code change is changing from the 2-level namespace of Hive to the 3-level namespace of the Unity Catalog. So if you use one Unity Catalog in your workload, then there is no code change required. You can simply set a default catalog in the cluster configuration, Spark configuration, or in the workspace configuration. Then what are the other code changes that you might need to do? We recommend checking the UCX assessment report. It will help you to plan those code changes. A few code changes that we had to do with credit analytics is to change direct file system access and DBFS mount access to make use of Unity Catalog tables and volumes instead. We did have to change some code. Some code was using RDDs APIs, so low-level APIs not compatible with Spark Connect architecture that is used on the Unity Catalog standard access mode cluster, so shared cluster. So we had to change it to use data frame APIs. So another issue we hit was the column level lineage in support in the common table expressions. So we did have to change, the team had to change column table expression to use temporary views to get the column level lineage working. It was quite a few changes, but we are waiting for some fixes to be shipped this quarter. So we are looking forward to test it. Finally, let me summarize what we have just discussed related to the UC upgrade framework. So given that the shared infrastructure, so the Databricks account and the regional metastores are provided by our foundation team, the infrastructure as code capabilities and APIs are provided to the business unit platform admins to provision their business unit level infrastructure. So business units can go and roll out Unity Catalog in 2 phases. So phase 1 is the Unity Catalog setup phase, the responsibility for the business unit level architect and platform admins. First, to design and set up the Unity catalog and plan the migration phases, as well as to install UCX tooling on the workspaces. Then in the phase 2 is for the data teams to use the tooling to upgrade their workloads, their data products and tables to Unity catalog. So you could see how the framework provides a migration blueprint. It uses automation and tooling, so infrastructure as code, APIs, UCX tooling. So it enables business units to roll out UC at scale. And with that, I will hand over to Floris to talk about the next steps and to talk about the results as well.
Thank you. Thank you, Taras. So now we have Unity Catalog, and what can we do with that, right? So for us, it was, we have quite a big complex data pipeline. And in the previous situation, we didn't have good lineage there, right? So we couldn't easily find out, like, okay, which sources are coming from what. You can ask the expert, but this person needs to look at the code and all these things. It's a bit, tedious in a sense. So we looked at different options, and with Unity Catalog, you get this lineage kind of outside of the box. There were little hiccups there that Taras mentioned, but we get this table and column level lineage, as you can see on the left-hand side in the graph. And you don't only get that in the visual graph, but also you get them in the system tables. So every line is actually represented in a row in the tables, and then you can use all kind of custom queries to make deep dive and analyze on top of that. Also, what a colleague of Taras made is like a kind of a visualization tooling on top of the Unity Catalog system tables where you can do all kind of graph analysis. So for us, it's really interesting to have these kind of things because we have a changing data landscape, and what happens to our data flow when one system is decommissioning? It seems some easy question, but without lineage, it's really hard to figure out what you need to do in the sense of which tables are affected, and you think, okay, it's only that, but it's actually much more. So yeah, now with lineage, we get much more deeper insights, and we can unravel this complex data flow. Moreover, so we need to do this, right? We need to get lineage. So if you're not getting an automatic tool, how we would then do it, right? So suppose you do it manually, right? We have approximately 400,000 column level, column level relationships to manage, and you would register them by hand, right? So you take approximately, ambitiously, you take 30 seconds per relationship. How long will it take, you think? Oh, we cannot see it here easily, but it says 135 days. So as you can imagine, is that if one person works 24 hours, only this, and we even go HR out of the door and we only focus on this, and if he works more than 8 hours a day, what I mean by that, we end up at 135 days. It's a lot. And also we run a lot of freezes in a sense, right? We try a lot of things, we tweak a lot of things, and every time something can change. So we don't have 135 days. We need to have something quicker. So now with Unity, it's available much quicker, of course, and it's available in 3 hours. I'm not sure if I should say much more than this, but yeah. So this was really interesting for us, and yeah. And now we get that with Unity Catalog on our complex data landscape. To summarize, right? So we had a data lakehouse. Actually, we came quite far with that, but we needed something to bring it to the next level. And Unity Catalog helped us with that. We could unravel the complex data flow with the column and table level lineage. We can get better access management on some tables. We have a lot of kind of sensitive data. We maybe want only one specific group to give access to the data. Now we can manage that. Finally, we can get our system tables and get much more insights in our operations, and we can tweak things. To do this at scale in an organization like Rabobank, you need to have a common framework. You cannot always figure out the wheel again. So as Tara showed, we made a good framework that can work at Rabobank that can be used at all the other workspaces as well. It's well documented, it's automated, so that we can rinse and repeat. And finally, now we're going to use this lineage information, democratize this lineage information in the wider processes. We also have, for example, a lot of data information in Collibra, and we try to mimic, to connect these things together. Finally, we can do much more deeper dives in our lineage information, do all kind of impact analysis on that. And finally, we continue our journey with Unity Catalog. So thank you so much. It was really nice to share our journey with us, and hopefully you enjoyed it as well. Let us know in the feedback sessions in the app. Thank you so much.